Hello and welcome back to our channel Oil and Gas Insights. If you are new here, do not forget to subscribe so you do not miss out any one of our HAZOP Studies tutorial. Today we are diving into another critical aspect of HAZOP analysis, that are parameters. In our last video we explored nodes, how to define and optimize them for effective hazard analysis. If you missed it, be sure to check it out after this one. In today's video, we will cover what parameters are, how to select the right ones, and how they impact your HAZOP study. By the end of this video, you will be able to define parameters with confidence and use them to refine your analysis. What are parameters in HAZOP study? Let's start with the basic. In a HAZOP study, parameters are measurable factors or conditions that are crucial to operation of a system. They include things like temperature, pressure, flow rates, levels, and concentration and composition. The key elements that influence the process. Think of parameters as the quantitative aspect of your process that we need to monitor carefully. Without them, we would not be able to detect potential hazards like overpressure, leaks, or deviation in flow. Why parameters are important in HAZOP study? Let's review our query, why they are important. Parameters are the backbone of HAZOP study. Why? Because deviation in these parameters, such as sudden spike in temperature or an unexpected drop in pressure, are often the first indicator of a potential hazard. Having the right parameters defined allows your HAZOP team to systematically analyze what they could go wrong and determine what impacts those deviations could have on safety, quality, and operation. If parameters are ignored, so poorly defined, the analysis could miss critical risks. How to select parameters for your HAZOP study? Now let's dive into the process of selecting right parameters for your HAZOP study. Here is simple step-by-step guide to help you. Review the process design. Start by thoroughly reviewing your process flow diagram PFD or piping and instrumentation diagram P&ID. Look for equipment and sections where parameters like pressure, temperature, and flow are critical. Identify critical parameters. Identifying the parameters that are vital for each part of the system. For instance, in a heat exchanger, the temperature and flow rates are most important parameters. Account for variability. Consider the range of each parameter. What are the normal operating ranges? What are the safe upper and low limits? This helps in identifying potential hazards like overpressure or overheating. Ensure relevance. Note every parameter needs to be examined in same depth. Focus on those that have greatest impact on operation or safety of the system. Common mistakes in parameter selections and how to avoid them. Just like the nodes, there are few common mistakes you might encounter when selecting parameter. Let's take a look at these and how to avoid them. Overlooking key parameters. Sometimes the team may focus too much on certain parameters and forget other that could be just as critical. Make sure you look at the entire system's parameter. Using too many parameters, including every possible parameter, can overcomplicate the analysis and distract from most crucial one. Keep it relevant and focused. Not considering operational changes, parameters can vary during startup, normal operation and shutdown phases. Make sure you define parameters for all operational scenarios. There is a great tip. Consider it. That is the regularly update the parameter based on actual operation data. This ensures that your HAZOP study reflects real world condition, make it more accurate and effective. Practical example, for example, parameters in a heat exchanger system. Let's look at the practical example to everything together. Imagine we are analyzing a heat exchanger in a gas processing plant. Temperature is critical parameter as we want to maintain a specific temperature differential between the two fluid stream. Flow rate is another important parameter. If flow rate drops too much, it could lead to ineffective heat exchange and overheating. Pressure in the system is vital for ensuring the system stays within safe operating condition. By isolating these parameters and understanding how deviation in any of them could impact the process, the HAZOP team can focus on potential risks such as equipment failure, contamination or overheating. There is also an advanced concept for optimizing complex system parameters. As we move into more complex system, optimizing the selection of parameters becomes even more important. Here are some advanced concepts which we must consider. Multiple operational modes. Consider the parameters across different operational modes: startup, normal operation and shutdown. The limits and the risk could vary between these modes. Dynamic parameter. In some process, parameters can change rapidly, especially in systems with fast response. Equipment use real-time monitoring and advanced tools to capture dynamic behavior. Sometimes software are also used, just like in node selection. Softwares are also used to optimize the parameters for HAZOP study. Let us summarize the today's session. To recap, parameters are the measurable elements of your process that are key to identifying potential hazard in HAZOP study. Selecting the right parameter is critical to ensuring a thorough analysis. Focus on relevant and critical parameter. Avoid common mistakes like overlooking or overcomplicating parameters. Always account for different operational mode and changes. Mastering parameter selection. Ensure that your HAZOP study is as comprehensive and effective as possible, identifying the risks that could otherwise go unnoticed. If you found this video helpful, do not forget to like, subscribe and hit the bell icon. To stay updated on our upcoming tutorial, share your thought or any question in the comments below. I love hearing from you. In the next video, we will dive into deviation analysis, a critical part of the HAZOP study process. Thank you for watching and I will see you in the next video.